Hi, I'm going to talk about sediment cells today, with a particular focus on the UK sediment cell number 2. So sediment cells act as systems with sources, transfers and sinks. Larger sediment is not transferred between cells, but some of the finer sediment can be transferred outside of this particular sediment cell. So for example, the soft boulder clays could disappear off out to sea or down to a different part of the coast. Okay, so let's have a look at this particular example, UK sediment cell 2. This is the Holderness Coast in East Yorkshire. Now, this has got sediment sources. So there are places at which there's going to be erosion, which is going to occur, and then we're going to get the sediment added to this system. So the chalk headland, a place called Flamborough Head. I've made another video on that, by the way, so I will put a link hopefully in the description to that, so you can re-watch that as well if you've not done so already. So chalk, Flamborough Head, there's going to be chalk that makes its way from the cliffs via erosion and is going to end up on the beach or wave cut platform. The cliffs are also going to erode, and there's going to be sediment inputted into the system from the river, the Humber. We've got the blue section here, which is going to be the movement, the transfers, the movement along the coast. And here we're going to have a longshore or littoral drift. The sediment moves from north to south. Some of the sediment, not too much, but some sediment moves offshore. The orange bits are going to be our sediment sinks. Now this is where we've got deposition. So there's going to be some sediment being deposited off the coast in offshore bars. We're going to have some deposition evident at the spit, which is here, which is called Spurn Head or Spurn Point. There's going to be some estuary muds deposited in the mouth of the river behind the spit. They might experience flocculation or gravitational settling. And there's some sediment that makes its way all the way down here onto this is the Lincolnshire coast, and into this place called the Wash, just before you get to Norfolk around the bottom here. Okay, so let's look underneath these post-its then and see what else we've got going on. So global warming and sea level rise is happening, and that's going to be affecting this sediment cell, causing, as we can see here, some positives and perhaps even some negative feedbacks, which is also linked to what we could call the sediment budget. So the amount of sediment available within a sediment cell is called the sediment budget. Within each cell, depositional features build up, which are in line or in equilibrium with the amount of sediment available. Now we can have positive feedbacks and we can have negative feedbacks. The system wants to exist in a thing called dynamic equilibrium, and sometimes with sea level rise and global warming, we might end up with positive feedbacks where there's a small change in the system and that change gets exacerbated, and that's bad. Unhappy faces. We could have global warming and sea level rise happening, but actually the system kicks in to correct itself, in which case we would call that negative feedback, and that's usually good. Okay, so global warming, sea level rise. These are going to upset the delicate, as I mentioned, dynamic equilibrium of the coast, and that's going to threaten to nullify the negative feedbacks which already exist. This could irreversibly damage the sediment cell, leading to perhaps faster erosion. Okay, so let's look at some positive feedbacks. Over here are sad face. A couple of examples then. Okay, so at Spurn Head, or Spurn Point, this is the spit down here. Rising sea levels, these lead to faster erosion of the spit. That's going to be meaning that there's more sediment being removed faster than it can be replaced. So eventually perhaps the spit is lost. It's breached and then lost. Another example might be up at Flamborough Head, the chalk headland up here. As we have more stormy seas, they are going to remove eroded material from the base of the cliffs more quickly. This leads to less protection being offered, and therefore erosion might speed up because the power of the waves, the erosional power of the waves, are going to be able to get in there and eat away at that wave cut notch more quickly. Another example, another sad face. Positive feedback, and this is going to be the Spurn Head sand dunes, which are just here. So storms can damage the dunes and create a thing called blowouts. So that's a big hole in the sand dune, basically. This allows more wind damage to the dunes, and erosion may be increased with the lack of vegetation that's then going to be there, and that gets worse and worse and worse, and eventually all the sand blows away, the habitat is lost, and there is irreversible damage. Now, let's have a look then at examples of negative feedback. This is where the system might kick in to correct itself. So, up to Spurn Head here. So, major erosion of Spurn Head could lead to increase in deposition offshore. This would create offshore bars, which would reduce the wave energy, so allow the spit time to recover, meaning actually it would remain. So that's a much more optimistic way of looking at things, how the system might kick in to provide some protection. And finally then, some negative feedback on Flamborough Head. An example of this could be that there is cliff collapse. This is the we talked about up here, where we have more erosion, the power of the waves causing Flamborough Head to erode faster. But this time we might look at it in a different way and think, well, major erosion event, chalk deposits at the base of the cliff actually might now slow down the future erosion, and the chalk deposit might then act as almost like a sea defence.